Hey, hi guys, good morning. Hi Neetu.
Hi, Shiva.
Hey, hi Vasu. Let's wait for a few more minutes so that others can join. Okay, by the time others also join, let me give you a quick recap because it's been so many days, right? We discussed HBase topics. So I gave you the HBase introduction on our last class. In our last class, last Thursday, I think. So HBase, we discussed about its pros and cons and the differences between the HBase and the Hive. So when should you go with HBase? So mainly Hive with OLAP, so same simple terms, and the HBase for OLTP. Wherever you need transactional support, there we should go with HBase. And if you need both the OLTP and as well as the SQL support, so then I told you that we need to go with the HBase and the Hive integration as well. And the pros side of your Hive is that it supports the SQL syntax, whereas NoSQL, it has NoSQL support. Okay, it has its own SQL syntax, but not the traditional SQL's standards or syntax. Okay, and we talked about the tables and namespaces also. I talked about namespace. Namespace is nothing but similar to database in HBase, and inside a database, tables and columns and column families. Okay, theoretically, I talked about all these things. Rows, row keys, and regions, and region instances that serve these regions, region servers, HBase Master, and the coordinating one is the Zookeeper quorum. And we also talked about a little bit on the updates. How does these updates happens, like through H files. We talked about H files and write ahead log, memstore, which is also called as memstore, and what else? Yeah, I hope you guys still remember these topics. Okay. Okay. Yeah, we also talked about cells, versions, and timestamps as well. Okay. So to quickly recap to the functionalities of master and Zookeeper and the cluster events again. So HBASE Master responsible for managing regions and their locations, meaning it assigns those regions to region servers, and it keeps track of that index in -root metadata table. Okay, and rebalance to accommodate workloads so that it equally distributes the regions across all the region servers. Okay, same functionality of your name node, balancing workload on the data nodes. The same way here, HBASE Master does that balancing of the data load in between your region servers. Recovers if your region server becomes unavailable. Okay, uses Zookeeper distributed coordination service. It is to achieve the high availability mode. So in case of HDFS architecture, there we had a backup name node and all those things to support the high availability. But in case of HBase, you will register, as I was explaining, an odd number of machines, mostly minimum three machines, or 5 machines up to 7 machines. Okay, so 7 machines will get registered with the Zookeeper quorum. Quorum is nothing but a group. So that Zookeeper service will always continuously be running on each and every machine. And to that service, these 7 machines or 5 machines will get registered. Mostly if your cluster size is 20 to 40 limit, or within that 20, 30, 40 limit, it would be mostly 3 machines get registered with the Zookeeper in real time. And if it is above 40 machine size cluster, then you will be registering up to 5 machines if your cluster size is up to 100. And if it is beyond 100, then you may go for, you can go for 7 machines service. Okay, and not beyond 7 is recommended. So if you register 7 machines with the Zookeeper quorum, and Zookeeper quorum is responsible for electing one of them as a master. Okay, so only 1 machine out of those 7 or 5 or 3 as a master. And that master serves all the requests of your clients, external clients. Okay, and if suppose if that master goes down, the next available machine in that quorum is elected as a master. That way, it achieves the high availability using the zookeeper. And HBase Master doesn't actually store or read the data. Clients communicate directly with region servers. So why? Because they first establish a connection with the zookeeper, and zookeeper establishes a session with the user, and during that session, zookeeper elects one as a master, and master finds the where all places this data that client is looking for is present in, and those region servers establish the direct connection with the client. The same way with SDFS architecture, where your name node is required until it identifies which data nodes to read from. And once the data nodes are identified from which the blocks needs to be read, you don't need to communicate through the name node, right? So the data nodes directly communicate with your user. And this HBase master is lightly loaded because it doesn't store any data in it. And responsible for schema management and changes, meaning adding or removing of tables or column families to those tables. Any metadata change or schema change, since it stores the metadata of all those tables, then that time only it gets involved in this. Okay. So HBase uses Zookeeper extensively for region assignment. Not just the region assignment. Its main purpose is to high availability. Okay. Zookeeper is a centralized service for maintaining configuration information, naming, providing distributed synchronization, and providing group services. Okay. So since all these masters register with this Zookeeper, and they also store some configuration information and names of all the region services. So whenever a Zookeeper session is established with the user client, and whatever the region servers that are needed to serve his request, they all also get registered with the Zookeeper as a ephemeral nodes. These HBase masters, the 5 machines or 3 machines, those are called the persistent Z nodes, and the region servers, they get registered temporarily with the Zookeeper. They called as ephemeral Z nodes. So that way, in Zookeeper, you will find 2 types of Z nodes, Zookeeper nodes. One is a persistent one, and second category is ephemeral Z nodes. Okay. You don't need to worry much about these types of things. In real time, you will not be dealing much with Zookeeper coding or something. And anyway, you don't have anything to code with Zookeeper. In Zookeeper, just to start the services and to register your machines with Zookeeper, those are just the commands, Unix-like commands. And that is also purely administered by your Hadoop administrators. Generally, Hadoop developers will not have access also to play with those commands. Okay, so it's not your job as a developers. It's not the developer's job to deal with your Zookeeper. So as long as your Zookeeper, you are able to connect with your HBase, that's it. You are good enough to continue your development. And if you're not able to make any connection to HBase shell or HBase programs or HBase Java client, then you need to raise a request or raise an issue to admin team. Okay, clients connect with a session to Zookeeper. Let me mute you all, guys. I'm getting some echoes. So clients connect with a session to Zookeeper. Session is maintained via heartbeat. If client fails to report, then the session is expired and all the ephemeral nodes are deleted. Okay. Once the client is registered with the Zookeeper session, so the client will always be sending the heartbeat messages at regular intervals of time. If client is not sending, means client got disconnected from the Zookeeper session. Then it flushes out all those temporary ephemeral nodes. And clients listening for updates will be notified of the deleted nodes as well as the new nodes. In case if it is requesting for any new table creations and it's storing that data on the new nodes, even those nodes get notified to the clients. And if it deletes, if it doesn't no longer need some of the nodes, then it can delete those nodes and then inform the client. Okay. So even if you are in real time, you are not going to deal with Zookeeper, try to understand the role of it. Okay. So that way, it makes your HBase high available and it reduces the burden on your HMaster. Each region server creates an ephemeral node. Master monitors these nodes to discover available region servers. Master also tracks these nodes for server failures, uses Zookeeper to make sure that only one master is registered. HBase cannot exist without Zookeeper. Okay. Yeah. You can see like these are, if you see, these are your master machines. So on this, your HDFS name node is running. On this HDFS secondary name node is running. And this on a separate standalone machine, HMaster is running. And on your slave machines, along with your HDFS data node and your YARN node manager services, the HBase region server daemon is also running on the same machines. Okay, for your Zookeeper service might be running on, as I was telling, so it will be running either on 3 or 5 or 7 machines, and they all will get registered with that service. And whenever you make a connection from outside, from your H node to the HBase, that connection happens through the Zookeeper layer. Okay, so that's the architecture point of view. And we discussed its data model and some of its key concepts. Okay, now let's get started with the hands-on. Just see how to create the tables and what is the syntax, and how to read those tables and update them. Okay. HBase installation, anyway, we're not going to cover. That's I'm getting a lot of echo.
Can you hear me now, Siva?
Yes, Anand.
So, Siva, quickly. Actually, I'm driving, but I do have a question for you quickly. I'm not clear. What is Zookeeper? How does it help HBase? That's not clear.
I think, were you there in the last class?
When was that last class?
Okay. Okay, it's better explain. It's better for me to explain from the beginning. Okay. Okay. So yeah, let me go back to some of the previous slides as per the Anand's request. Zookeeper, I think you were not there when I was explaining this slide, Anand. The purpose of the Zookeeper is that So you will have an external client here. So I hope you're able to see the screen. You have an external client running on Edge node here, okay? And you have your HBASE master, and you have some set of region servers, okay? And you can have multiple master machines on which your HBASE master can be running, but only one out of them will be active. So who will decide that is your HBASE master. Let's say if you have 3 machines on which your H master service is running, and all those 3 machines got registered with Zookeeper. Okay, treat like Zookeeper as a gateway, and all these 3 machines got registered with your Zookeeper. Now, you made a request from an external client to the Zookeeper. Your intention is to directly fetch some HBase table, but that request flows through Zookeeper, and Zookeeper identifies which one among the 3 registered machines is the actual leader currently. So if 3 master machines get registered with Zookeeper, all the 3 will not be masters at a time. Only one out of them will be active. So this Zookeeper comes to know that which one is active. Okay, if that one out of them goes down, then Zookeeper has the ability to elect a remaining 2, one among the remaining 2 as a master. That way, if one master goes down, immediately second master can be active in HBase. This facility is not there in your HDFS architecture. So this is one point. This is one significance of your Zookeeper. And second thing is that once the connection is established to the master, and it knows that which tables the user is accessing, and master has the index on where those locations are present in region servers. And region servers, so it identifies what are all the region servers it should serve to the client. And these region servers will get registered to the Zookeeper as a temporary Z nodes, FML nodes, and those will establish directly connection to your user. Okay? Did you get it, Anand? Or still lost? Anand?
So looks like, sorry, I was muted. I unmuted myself. I think so. I may have some follow-up questions for now, but you can move forward for now.
Okay, I mean, that means it's still not clear for you.
No, you know what, actually, since I'm not visualizing it, to be honest with you, that is the reason, but that should be okay. You know, we can move forward. I'll probably ask you some follow-up questions.
Okay.
That's all. Thanks.
Yeah. Okay. Now, same like your HBase, same like your HDFS installation, 3 modes that we can do: the standalone mode and pseudo distributed mode and fully distribution mode. So HBase also can be installed in all those 3 modes, and we'll be working mainly in the pseudo distributed mode on our fixed VMs. Okay. So when you are running in standalone mode, local mode, this is as good as like running in the same JVM all the services. Okay. And you don't need to worry about this at all ever. You'll never be using it in real time. And coming to pseudo distributed mode, you will be running it in your fixed VMs. It requires HDFS. It has its own services running in the machine. but all those services running in the same machine. If those services gets distributed into different machines, then that becomes the fully distributed mode. Okay. There's anyway, it's not interested for you. Installation of the pseudo distribution mode. Of course, your quick start VM comes with the already HBase installed there. Okay. Maybe in case if you face any trouble in your services, I will give you 3 commands. Play with them. Okay. So those are like sudo service, HBase Master, HBase-master. These four options you might be already knowing by now. Status, start, restart, or stop. Okay. This is to stop your HBase Master. And similarly, you have sudo service, HBase region server. Okay. And sudo service Zookeeper server. If you feel like your HBase services, HBase daemons are not running, so how can you verify that? Go here and sudo jps -lm long messages. This says that quorum peer main Zookeeper quorum is running, and H region server is also running, HBase region server, and there should be somewhere H master is also running. Okay. So all the 3 services are running. As long as 3 services are running, you are good to play with your HBase. Okay. And to start with your HBase, just HBase shell. And it uses in the background, if you guys are aware of Ruby, it uses the same JRuby shell, and it has the similar functionality of that. Okay. So one good thing with HBase is that you will get a very good documentation in HBase shell itself with the help command. Not like, unlike your Hive. In Hive, you don't get your documentation for all your commands in shell with help command. So just type, in order to launch into HBase shell, the command is HBase space shell, same like your Impala-shell or Hive command. And now just type the list command to list all the tables present in your HBase. Currently, I have only one table EMP. That is. So if this gives you results, that means your HBase is running properly. If this doesn't give you results correctly, and if it says that HBase Master is down or can't access the Zookeeper node or anything related to that, something went wrong with your services, then try restarting all those 3 services that I have given you here the commands for. Okay. So here, since we have all the services running fine, the list command is working fine. So list is similar to show tables in Hive. Okay. And if you type help, you can get a lot of details. If I maximize this, I don't have the command. One second. Not able to minimize this. Just give me a second. Something went wrong with this today. Okay. Let it be. Yeah, it's not getting minimized, but let it be. Without the slides also, I can tell you these examples. So the help command displays you the list of all the commands that you can play with your HBase. This is the complete list of commands that you can play with your HBase at max. Complete list. Meaning, I can say this is very small set of commands available with your HBase. You don't have plenty of commands here. Let's see some of them. And if you don't know the syntax also, that's fine. And you can get the help of those commands here directly. Let's say if I need to play with the create namespace first, yeah, let me explain you about these categories also, groups also, group names general. These are some of the general HBase commands. Status will give you the status of your HBase, whether it's running fine or not. And table help, something related to help on table. Version will give you the HBase version. Who am I gives you the user with whom you logged in. And these are some of the DDL statements at table level. And alter is to change the schema of a table. And alter asynchronous. Alter means this is a synchronous command, synchronous version, and this is the asynchronous version. It doesn't wait for the action to be completed. It throws you the results back quickly. And create table. This is for creation. Describe, same as in Pig, Hive, Impala. It's even in HBase. This describe is for same purpose, to view the schema. And disable, keep the table in HBase, but disable it so that it will not be available for querying. Okay. and disable all also to disable all the tables, and drop all. Drop means completely removing the table, delete table. Okay. If the table is disabled but not dropped, then you can re-enable that using the enable command. Exists to check whether that table is present or not, and to check whether this is disabled or enabled. Okay. List is the command to equivalent to show tables that we have seen already. And filters, we can see some of them going down. Okay. And these are all at table level, and these are some of them at database level, like creating namespace and describe namespace, drop namespace, list namespace, all these things. Okay. And DML, these are data manipulation language commands, like count to get the count of the table, record count, and delete some records, and get some records, and put, update, insert, update the record, scan to retrieve all the records. Anyway, we'll go through, I will show you examples for each of some of these popular commands. Okay. And these are tools, and generally we don't deal with them. As I was telling you theoretically, compact and major compaction. Compact is a minor compaction. This is a major compaction, and all these commands will be useful for administrators, not for the developers. Developers will not have access to these commands. Balancer, okay, merging regions, moving, splitting. Okay, these things will not be available for developers in real time. Anything related to these configurations also not available for grant, revoke. These are all out of scope for developers. You can limit your practice just to these two, these three max. Okay, DDL, namespace, DML. Okay, I didn't give the examples for DML, this namespace commands. Maybe you can try it here itself. Like if you have any doubt on any of the commands, like create underscore namespace. So it's very simple. It has shown us the commands to do that. The syntax is create underscore namespace. Let's say it's like our DB, right? NS1. I can create sample DB or namespace, anything. I'll create this. And if you want to see them, list namespace. You can see HBase is one namespace and default is another namespace and sample. In the same way you have seen in Hive and Impala, default is the default database that is available in Hive and Impala. Here default is the namespace that comes by default. Okay. Here you don't have use like commands. In order to refer to that namespace and create any table inside that, you have to specify that using that qualifier. Okay. And alter namespace is not much useful. It's like just adding some property names and values, same as in your alter DB in Hive or Impala. Alter database in Hive, that also not much useful, right? It's just to add some, it is just used to tag some values to the database. Okay, so let's not worry about that. Just create namespace and list them and create table. Let's see now how to create the table. Help create. So there are so many versions of this, so many ways of usage of create table. Okay, so if you see these examples, I don't have access to the slide. It's not getting minimized. So that's why I'm taking the help of this shell itself to explain you these commands. Okay, just let me know in case if you're not comfortable with this font or not able to clearly see these things. Okay, so create a table with namespace ns1 and table qualifier as t1. Suppose if you want to create a table called t1 under ns1 namespace, you can do this way, like create namespace colon table name, and you have to observe that I have given that in a single quotes. Okay, followed by name arrow F1. F1 is for specifying. This name arrow is used to specify the column family names. Here names represents column family name. And how many versions you want to maintain for this column family, that you can specify. And you will see this notation inside curly braces specifying using usage of arrows to specify the values of attributes. Okay, and in case if you want to create a table with default namespace, you don't need to specify that ns1 colon or whatever that namespace colon. Okay, so create t1 and column family f1, f2, f3, three column families. And the equivalent for the same one is, you can specify this way also. Create table t1 and f1, f2, f3. If you don't have any additional attributes that you want to specify along with these column family names. Unlike just specifying the column family names, if you want to also specify some of the versions, how much time this column family should be active, and any other attributes, you can specify this way. Curly brace notation like name f1, versions, how many versions? Only one version instead of default 3 versions. And TTL is for time to live, how many seconds this column family should be active. And this is one of the very good feature that because this HBase is mainly intended for storing the OLTP, right? And OLTP doesn't store the historical data. So once it becomes 1 month older or 15 days older, sometimes we don't require that data to be present in HBase. Once it becomes 30 days older, you're no longer interested in storing that data, and you should copy that data into some of the Hive tables or somewhere else. Okay, so if that is the case, you can set your TTL, time to live, in number of seconds, and once the time TTL gets expired, those cells will get deleted. And this is to enable cache on those column families, and any other configurations, extra configurations that you want to specify, you can specify them. Okay. And these configurations we generally don't specify in real time. Let me try minimizing this. Something wrong with this. Just let me try 1 second. It's not getting to. Let me kill this VM and restart that VM. Okay. I will end this task. That's troubling me a lot. Okay. It's available here. I will keep it as it is, the same things. Okay. So we have seen this HBase shell and list commands. Yeah, and if you want to see where exactly this is present in your HDFS, as I was telling you, right? So HBase data also gets stored in HDFS only, and this is the location /HBase is the root location where it stores the data there. If you want to verify that, but those HDFS files are not human readable. Okay. This is where you can see all the WALs also being written into this vals right ahead logs, and this stores your HBase version, and this stores your actual HBase data. So if you go inside this, you can see the tables and their regions. You can see the namespace. Namespaces information somewhere stored in these files. Just now I created a sample DB namespace, right? So for that, it created a folder called HBase data sample DB. And you have observed their HBase namespace also. That is here. And under the default, I have a table called EMP, and these are the details of that EMP table. Okay. So anyway, these are not human readable HDFS files, and you can't even read these files through your MapReduce or PIC or any way, directly reading these H files. Okay. Now, Yeah, same like your HDFS having a web browser interface. Here also you can access the HBase comes with web-based management. Your master can be accessed through the port IP address or the host name :60010 is the port number where your HBase Master runs. You can see all this basic information from there and there as well. Since my master is running on this machine, I use this 600010. You can see this. So how many region servers are there? Only one is there that is running on this machine. So if in your real-time cluster, you can see 10 or 20 here, please. And number of regions on this region server, currently there are only 3 region servers, regions on this region server. And any memory related stuff you can see. Okay, this is your master. And if you want to see the table details, you can see them here. So currently there is only one table EMP. That table, the table name EMP is present, and its description, the describe, the result of your describe command is printed here, displayed here. And how many other tables are there? All those tables list will be displayed in this page for you. And if you want to check the logs of your daemons, it could be your HBase Master or region server or Zookeeper also, I think. If not Zookeeper, all HBase related log messages. And if you want to control those log levels, only the you can set the property, the log property, and set the level as info or debug or something. This is purely for administrators. Okay. And HBase configuration, if you want to verify your cluster HBase configuration, you can check that here in this. So this XML file will contain all the configuration properties that are being used for your cluster. Okay. These are all the underlying MapReduce and HDFS, CFS.default name. Underlying HDFS, MapReduce, yarn, and HBase properties also included in this. Okay, so this is a bit about the web browser interface for your HBase. Okay, and except that log level setting, rest all are read-only information from your web browser, same like your HDFS web UI. Okay, and HBase shell we have discussed about. Yeah, these commands I have given in this slide. Just play with your services. And some of the things that you need to keep in mind is that quote all names, meaning the table names, it could be column names or it could be value names, anything that you pass as an arguments to your commands, HBase commands, they all should be in single quotes. Otherwise, you will get a syntax error messages. Except these extra parameters that you specify through the curly braces, remaining all should be in single quotes. Okay. And in case of if you have any binary data, then you should specify them in double quotes. And these are the commands that I was just showing you in this shell. So general commands, DDL commands, and DML commands, and administration commands. And for create namespace, we have just created a namespace called sampledb. And status is something, this gives just the status. Status, how many servers are running, how many are dead. Okay. What is table qualifier? Table name, table qualifier. Just it gives you how many servers are running. In case if you want the detailed description of this, you can give this anyway. You can get it through the web browser also. So how many live servers are there, and what is that region server that is accessed? It's same as your web browser interface. The same like your home page. Okay, the status detail. Now let's enter into the actual commands of tables creations and data insertion into that. Okay. Let's create a table and populate data into it and access it and edit the data, delete the records and drop the table. And these are the typical operations that you perform on any tables, right? So let's go through each and every operation here. Okay. So for create tables statement, we have seen varieties. With the help of shell itself, we got the syntax as so create table, table name, and column families. You can specify two ways, either directly listing the column families names F1, F2, or using this curly brace notation like name arrow F1. Similarly, either of these two options is fine. Okay. But by default, if you create a table in your pseudo cluster, okay, not in real-time cluster, in your pseudo cluster, the replication factor or the versions it maintains is only one versions. Okay, let me create the table and show you that. So I'm in HBase shell. So table T1 is created. So you can verify its schema by describe T1. You can see the column families F1 and F2 got created. Okay. And if you keep all these things aside, if you can check here, versions equal to 1. So by default, it created only one version. So if you have only one version, you can't specify the updates. You can't see the previous values, previous versions, you can't access them. So for that reason, I will create some table with 3 versions. Next. Okay. So in this simple exercise in our slides, I'm going to create a table with 2 column families. one column family name is info, and second column family name is content, and the table name is blog, info, content. And columns are 3 columns I'm going to maintain in info: title, author, and date. And under content family, I'm going to maintain a column called post. Okay. So to create this, the various versions are like, so create blog, name info, name content, and I want to maintain the versions as well. Okay. So comma versions, I will specify. So what is my table name? It's blog. And my column family names are info, comma, content. Right? And how many versions I'm going to maintain? So I want to maintain minimum 3 versions. Versions 3, same here, versions. So now this block table got created. So if you list, you can see all the 3 tables. So block table is there. T1 is just now we created, and EMPs was already there. Okay. Now the block table is empty. And if you describe it, describe blog. Here we have 2 column families, content and info, with the versions, 3 versions. Okay. Did we specify any column names here? No. We are not specifying the column names at the time of table creation. So we'll specify those column names at the time of data population. And this is my sample data, which I want to insert into the table. So I have 2 column families, info and content. And under info, I have 3 columns, title, author, and date. And under content family, I have post. Now I should be maintaining 1 row ID, right? So that row ID, I have these values. Okay. So in order to insert into a HBase table, you can put your data only 1 cell at a time. And you have that syntax also similar to that nature only. You can't insert more than 1 cell value at a time. If you see here, the syntax, put command syntax itself is put your table name followed by your row ID followed by the column family, column name, and its value. Okay. So you can specify the table name, you can specify the row ID. So you are limiting to 1 single row. And within that, column family and column name also you are specifying. And then you are providing the value. Meaning, it will get inserted only to this. Let's say if you specified the row ID as some value, under that row, if you specified info as title, family as info, and column as title, and if you specify elephant, only this cell value will get inserted there. Let me take this and so one thing you need to observe here is that So in this block table, so in order to insert the title, I am using one put statement. Okay. Let me use this. So this got inserted. How can you verify this? Whether by reading. So we have a select star command from table name. Its equivalent in HBASE is scan table name. This is same like select star from table. You can see here your row ID is mat-001 and the column and cell value is that. Under info title, value is elephant. If I want to insert the remaining 3 column values also, I have 3 more columns: author, date, and post. Right? I need to make 3 more put statements. Now, if I use the scan, you see mat-001, post is do elephants like monkeys, and author is Matt, and date is this one. Title is elephant. Okay, so here you have 4 cells. Here you have 4 cells, right? So all these 4 cells belong to just one row. But when you scan in your HBase cell, you can see them as 4 records, 4 lines you are getting. You should not get, you should not count your records with these lines. You should see the number of rows at the bottom. How many rows it is? It's just one row. Okay, so all these lines belong to just one row, and you will get cell level information. So you can control your data storage at cell level. Now you use that put statements to update this, right? And if you want to change the, let's say if I want to change the author, so info author, instead of Matt, I want to change it to Ramesh. Just that's it. Keep the same table name and the row ID, and you wanted to change the author for this table, for this row key, because the row key is always unique. Under this row, for this column, you have updated your value. Now, if you scan your block table, you can see Ramesh's value available here. And this was so quick enough, right? So that Ramesh got updated so quickly. Now, Ramesh is the author for this. And if you want to refer back to the previous versions, yes, you can. You have under scan, you have how many versions you want? 2 versions or 3 versions? Just keep that. You can see if you have multiple versions, you will get, otherwise you will get only the latest version. So for content post, I got only the latest value. For info author, this is my latest value, and the old value is that info author, it was manned. And info date, I have this value, and info title, I have this value. If I have multiple versions, they all will get displayed, these versions. Okay. So if you observe this, just to insert one record, you are making so many put requests, right? Since here you have only 4 columns distributed into 2 column families. So based on the number of columns, those many number of put statements you have to write. Let's say if you have 10 columns in a table, typical table size, right? 10 columns means 10 columns, and assume you have 1,000 rows or just 10. So for this you need to write 10,000 put statements. Put statement. How many are columns into how many are rows you need? Those many number of put statements you have to make. Obviously, this is not possible through manual. We have to write it through either Java commands, either we should interact with your HBase through Java programs, put that in a loops, for loops in Java statements, and then keep inserting into your HBase tables. That is one option to do to bulk load data into your tables. The other way is if you have your data in tab separated format. So HBase gives us one jar that is available in HBase libraries. So if you invoke that jar, that submits a MapReduce job, meaning in the behind the scenes, it's again the Java programming, the MapReduce programming that reads in your TSV file, tab separated file, and inserts them into the appropriate HBase columns and values. Okay, so even though this put statement is available for us, but in real time, this is not much useful because you can't insert records cell by cell. Okay, either you have to achieve it through the Java programming or through that MapReduce program. Using that MapReduce program, we have to load it into the tables. We'll see how to do both the ways. Okay, I'll cover that. And for our practicing, let me just insert few more records. Okay, let me insert a few more records into it. Okay, that is one record. Okay. I'll just insert one more record into it. Okay, now if you scan the table, scan block, you can see 3 rows. And you can see them alphabetically, lexicographical order sorting. Like Anand came first because A starts with, and then Z, and then M. Okay. Now, so the scan is complete scan. It's like a select star from table. Let's say if you have 10,000 records, if you just want to get one single row, you can't use the scan. And if you want to access a particular row ID, you have a get command available to retrieve a single row given a row ID. And same way, if you want to get the select count star, if you want to get the count of rows, you have the count command. So the simplest way of usage, it says count and table name. Just give the block. Prints me the 3 rows. Total 3 rows are there in this table. So generally, this count command by default keeps on printing every 1000th or every 1000th record, I think. Okay. So if you want to skip that, you can specify the interval, an option called interval arrow. Generally, this will be used when you are dealing with very huge tables. So since if you have 1 million record, if you call count on that table name, so for every 1000th record, it keeps on printing that row ID of that 1000th record. Okay. So instead of doing that, you can increase this interval to 10,000 something. Then it prints that row ID for every 10,000th record. Since here I have only 3 records, let me print the row ID for every 2 records. Just current count 2, and the row ID is John 005. If I would have 4 records, then it prints me every second record row ID. Okay. That's the count command and interval option also. And next, the get command. And you had the million records table. Since you can't use the scan, you can go for the get command and get table name and followed by the row ID retrieves only that particular record. Get block math-001. So it returns me only that particular record. Okay. So here the result of your get command will always be only 1 row. Okay. So don't get confused by these 4 rows. This is just, it is retrieving the columns. Okay. Here you can see the post column and author column, date column, and title column. And in get command, again, if you want to narrow down to one particular column, you can specify that column. And suppose if that row ID is not there, so it will not result any value. If it is there, and if you want to further narrow down, you don't want all the column values. You just need only one column. Okay, just specify column equal to. You just need info and author. And author also, you need 3 versions. Okay, or 5 versions. How many versions are there? You got only the author. For this row ID, only this row author. And how many versions? 5 versions you need. Since you have only 2, you got those 2 here. Okay. And how many are columns that you want? You can specify them in comma separated list there. And you can also specify the time range between these time ranges to this time range you want, you can get them. Only those values, only those cells that got updated between those dates and those timestamps, those will get returned. You can select specific columns, you can select specific timestamp or time ranges. You can select more than one version as well. Okay. If you give the unknown row ID, you will get 0 results. And if you want to select the columns, this way. And if you want to select the timestamp also, yes, this way. And specifying the versions we have seen. Next, the scan command. Let's see a few more options that we can play with scan. So basic scan we have seen. Scan with versions also I have shown you. But select star limit 100. Select star from table name, limit 100. So that one you can achieve this through scan table name, limit. If you give the 100, even if it is 1000 record table, you will get only the first 100 records. Scan block. So it gives me only the first record. And this is in lexicographical sorted ordering. So Anand comes first in your scan result. And since you limited to only one row, so it printed you only the first row there. Okay. You can use the limit along with scan. Okay. Can you please explain the timestamp format? This is epoch timestamp format. This is not your, this is Unix timestamp format, like epoch format. This is the number of milliseconds that between your standard epoch time format, like 1970 Jan 1st midnight. Okay.
Okay. So Shiva, like you were mentioning, we can specify the timestamp range.
Yep.
So how do we specify the range? How will we write the timestamp?
Shown you the syntax here, right? In this. So time range TS1, TS2. You can specify them. Or if you want me to show you, I can show you here. Simple. It's like, again, if you have any doubts in that,
Yes.
help, just use the get. You can specify here. If it is just one timestamp, you can specify this way. And if you have time range, if you want to specify this way. And since we have seen for author there, let me show you that. Yeah, this one, right? Let me show you get log. You have to specify the timestamp in the same epoch format. Okay, not like your typical dates, MMDD, YY formats. Okay.
Okay.
So you have to specify these. That's one. And let's say if you want the column, specified info, author, so time range, time range. You can see between these two time ranges, there is only one value. And whenever you give any range kind of way, so the lower boundary is inclusive and the upper boundary is exclusive.
Okay.
I was showing you in regions also, right? Row ID in one of the slide in last session. So when it shows any range, the lower boundary is inclusive and the upper boundary is exclusive.
Okay.
Okay.
Okay. Thank you.
Yep. So you can play with that. And you know the get commands and scan commands. Scan with versions we have seen. Scan with limit we have seen. Scan with start row and stop row. You know the row ID, like select star from table name, where your primary key or the employee ID 0 less than employee ID less than or equal to 100 or less than 100. So that query, if you want to write in HBase, you can use start row and stop row. Okay, you can specify scan block. So these options mainly useful when you have millions of records. Okay, scan block, start row. Obviously, you have to give in the same order. Let's say I have Anand. And stop row. Chan-005. Here again, whenever I specify any range, as I was telling you, the upper boundary is exclusive. Only the lower boundary is inclusive. The start row is inclusive. Stop row is exclusive.
If you have a question.
Yes, Lakshman.
How are the row IDs generated?
Row IDs, we are only giving there, right? At the time of insertion. Row IDs
but
do not get generated by default. We only have to specify the row IDs.
So while doing the programmatically, how do we generate? Just some sequence number we do that?
It's not the sequence number. Generally through the combination. Let's say if you are inserting an employee details. So you know that employee ID should be made as a key in case if you are using Hive or Impala. Anyway, you don't have primary keys concept there. You don't have sequence generators there. You keep on incrementing the number, get the max value, and +1, and insert the new record into there.
Okay, sounds good. And on the date, how do we know the date value? I mean, this name, how do we remember this? I mean, if you have to give a date range.
Timestamp?
Yeah.
Good question. See, we don't remember these timestamps in. We just need to convert. So let's say if you have in your Java or any programming language, if you want to convert any date range, convert it into milliseconds.
Yeah, got it. That's okay. Sounds good.
Those time ranges.
Yeah, any time range we want, there'll be equivalent function to convert in the epoch format and use that too. Okay.
Yes, exactly. In Java, you can use system date format or something. Simple date format. Just convert that into get system time milliseconds. You'll get this date.
But we cannot do in the get scan or the get thing, is it?
Scan or get thing. The actual date here?
Yeah.
No, actual date you can't give it here in this format.
You mean some conversion, got it. Okay.
You always have to give it in the epoch format.
I see. Okay. Thanks.
Okay. Yeah. Now, we have seen the start row and stop row also to limit. And while scanning, if you want to limit to particular columns, only you don't want all the four columns, you just need only 2 columns, then you can refer to this. Just specify the columns : and info : author and content : post. You can get only the 2 columns. And you can also specify the time range. You can also specify the filters also, where classes, where value filter, like it's not that matured as your where classes and your select queries, but some of them are helpful. Like, so you can use value filter to search. This is like a free form search in all the columns. Value filter equal to binary prefix Mickey. It searches for this Mickey string in all the cells. Okay. If I have to show you value filter, sometimes this will be helpful. Scan block. Value filter. You have to specify the values here. So value filter equal to, it's a binary. These are all like syntaxes, okay? Even I too don't remember these things. I need to close this. So this is for equality checking. Mostly we'll be doing equality checking on the value filter equal to binary prefix of Mickey. And since everything gets stored as binary or bytes, whatever the string that you pass, that will get converted into binary by using that binary prefix colon. I'll match it to that. So there was one row and there was one cell, content post with Mickey Mouse. We got only that. Okay, these syntaxes will be a bit difficult to remember, but you can refer these slides. This is like a value filter, and if you want to prefix filter, like This is a row ID prefix filter, row starting with John. You can use that prefix filter. Prefix filter of John. You will get only the John records. Anything that starts with John, you will get there. Okay, this is a like star, like search on row ID. This prefix filter works only on the row IDs, and this value filter works only on the values part, not on the row IDs. Value filter searches only on this, and this prefix filter searches only on the row IDs. Okay, now if you want to get only the keys but not the values, you have few other filters like, so first key only filter, key only filter. So if I use key only filter, and this is generally used along in programming. It returns only the list of keys, all the keys, but not the values. Key only filter, just calling that. So it called only the keys. Values didn't capture. Values are empty. And if you just specify first key only filter, it gives you only the first key. This is the difference between them. The key only filter, for each and every cell, it retrieves the keys without values, but first key only filter, only it retrieves key once. And this is generally useful for traversing through all the rows, Java programmatically. It returns only the keys. Okay, and any advanced filters, if you want to refer and if you want to check, you can check on this article, HBase functions cheat sheet. You can refer this sometime later. Any further filters on that? And without specifying the start row also, you can give the stop row. Then starting from the beginning, it scans through until it reaches this row ID. Okay. Next, editing the data, updating. Put command inserts a new value if row ID does not exist. But if the row ID is already present, then it updates that value that we have already seen. Okay, but does it really update? No. Insert a new version for that cell. Only the latest version is selected by default. And by default, 3 versions are kept. And if you need more, you can specify this column families. In your sudo distributed mode, in your quickstart VMs, the default versions is only 1. And if you want to play with versions, you need to explicitly specify the versions as 3 or 5. Okay, so here I'm using the same put statement, put table name, row ID, and column family, column name, value. So it's July 6th, July 7th, July 8th, updated. and all the values if I retrieve. At the time of retrieval, I should specify the versions, how many versions I need. Otherwise, I will get only the latest value. Okay. And similarly, if you want to delete a record, just have a delete command. Delete table name, row ID, and column name. And all the 3 parameters are mandatory. Meaning, this delete command is used only to delete a cell value. And there is one more command called delete all that is used to delete that entire row. Okay, this delete just deletes the one cell, and delete all deletes the entire row. And if you want to delete only one particular version or one particular timestamp value, even that is possible. And by default, it deletes all the versions of that cell. Let's say if I want to delete blog, comma, and 001, and what is the column that I want to delete? Info, author. Now the Ramesh record should get deleted. Now if I use the get of blog, out of 001. See, only that particular cell got deleted. Post, date, title, all 3 other columns are present. The author cell value got deleted for this record. If you use it scan, and if you use specify raw equal to true, under mat, you can see the deleted columns also. If I specify raw equal to true, since this is not already hard delete, it's just as I was explaining you when we are discussing theoretical concepts. It's a soft delete. You can see for this info author, type equal to delete column and value equal to Ramesh. Okay, you can see the deleted column values also in case, but you can't see the multiple versions of it. For your reference, I will paste. Okay, and you have delete all, that is delete all command for deleting the entire row. So this delete all, just specify the delete all and give the row ID. So let's say if I have mat-001, I should specify the table name, of course. Okay. Now if I scan it, scan raw true, this entire delete family, it has gone type. Everything got deleted. Okay, both the families got deleted. Delete content, delete family, and info is also delete family. If I don't use scan raw equal to true, if I don't specify raw equal to true, simply get it. Only these two rows, Anand and John. Okay. So that's the usage of delete and delete all. And if you want to drop a table, so first you should disable that table and then only you can drop the table. If I simply try to drop it, drop blog, table blog is enabled, disable it first. Okay. So to disable it, disable blog and drop block. Now if I list this, only EMP and T1 are present, but not the block table. Right? So I don't have that block table anymore with me. Okay. So these are the operations that you can play with these tables. Now, let's see one of the important bulk import use case. So bulk importing through the MapReduce utility, MapReduce import TSV utility. If you have your data in a TSV format, you can use this. And writing through the Java client, HBase Java client, we'll see tomorrow. But for today, we'll see this, the bulk import utility. Let's say I have a table called EMP. One more thing I should display, I should provide you one more command is that truncate a table. Truncate was not there earlier. So now we have delete all. Delete all command for deleting the entire row, and truncate command for truncating all the record. Truncate command for deleting all the rows at a time, but keeping the schema. You can play with that. Now let's say if I have an employee table, I have these records, okay. So I want to truncate. So if you see, it is disabling the table and then truncating its contents. Can we have a rollback command if we want to undo changes? No. We don't have a rollback commands here. We don't have rollback or commit commands here. Okay. Now you have seen truncate also, scan EMP. Now there are no rows in it. Okay. So let's suppose I have this table still I have this table. I don't have the column names in this. Let's say if I want to load data into this table. Let me see. So I have description, I have info, two column families. Or if you want to take your blog table also, as an example, you can take that. So bulk importing approach is that you need that table to be present in HBase in order to load the data into it, right? Otherwise, your utility can't create the table for you. Create blog with two column families, info and content. So I'm again creating the same table, blog table. I have this. Now we had 4 columns in these 2 column families, and so we were using separate put statements every time, right? So instead of that, so let me write down this into a tab separated format. Instead of these many put statements, I will take this mat-001 tab and use this elephant tab, and author, instead of mat I use Ramesh. Use date some 2016 -10. Any values you can provide. Okay, there is no syntax, there is no typecasting errors, there is no casting exceptions, because everything stored as bytes. Okay, you don't need to specify the data types. You can insert any data into it. It accepts. Okay, 2016 0706, and I specify a string. Just elephants something. Okay. Now the second record, I will take this into tab separated format. Having data in tab separated format is very typical, right? Since I have input statements, I'm taking this much of time. And 2016 070705. Okay, I take cats. John 003. Okay, is mouse. And it's John, and it's 2016 0707 Mickey Mouse. And this way, if you have n number of records, you can specify them. Okay, so if you have Neetu and (2016). Okay. Now I have this data in tab separated format. If I have data in tab separated format, I will store this in block content dot tsv. Where is that file? Yeah. I'm saving it. Okay. Now, to use this bulk data, I should have this data in HDFS. This data should be available in HDFS. So what I will do is, I will load this data into HDFS. Sorry. Hadoop fs hyphen put blog content.tsv /user /cloudera. Okay. So I'm just uploading it into here. So now the workaround, so instead of using so many put statements, the one command that I can run now is the HBase. Let me explain you this here. Command is that HBase and HBase MapReduce.import tsv hyphen import tsv columns you have to specify. So what is your row key? Your first column or whatever is percentage is the row key. The second column is info title, and third column is info author, right? So, and followed after that info date, and after that content post. And into which table? This is into the block table. And where is your file located in HDFS? This is blog content .tsv. This is your HDFS file path. So HBase command followed by the import tsv, the class name, and you have to specify the columns, import tsv columns. The first column is a row key, and following after that, all others are your actual column values. If you use this, it will submit a MapReduce job.
Ishu, I have a question while it is going.
Yes, Lakshman.
So is it a normal practice to create a TSV file and then load it through this approach?
There are two approaches. One is through this, and second one is directly having your Java program, Java clients, and through Java client, you will directly insert into your table.
Right. That must be the most commonly used approach, isn't
Most
it?
commonly used approach.
Yeah. Okay.
There you can create a put objects and directly keep on inserting into the HBase table.
And what is the typically source of the data? Is it a website content or stuff like that?
Typical source of data, I mean, something that you upload from your local files or anything that you already have in your HDFS or some places. Any semi-processed data. Like any raw data you can get, and once you get the raw data, you use pig or MapReduce to make them structured. And then once it is structured, if you feel like you want to maintain updates on that data, then you will load it into HBase. Otherwise, you will load it into Hive, right? So into either of these databases, you will maintain your data in any of known formats like TSV format or comma separated formats, that way, right?
Okay.
So if it is Hive, then there you will load it into your temporary Hive table, and from there to ORC or Parquet compressed formats tables. And if it is HBase, you will load it from the CSV or TSV formats into your HBase tables.
Okay. In terms of, I'm sorry to interrupt, but in terms of business use case, what is the use case for the HBase?
Business use case, the same thing. Like whenever you need updates to the data, you need to do HBase.
I see. Okay.
And now just we created the block table and loaded the records into this, right? And now if we use scan, you can see all the 4 rows got inserted. Otherwise, I could have used 4 into 4, 16 put statements. So if you prepare your data in tab separated format, and if you can use this utility, bulk import utility, you can load n number of records, any number of records, millions of records. Okay, and tomorrow we'll see the HBase Java client using the same Java. How can we insert? How can we create a table? How can we insert records, and how can we get those records back? Whatever the operations that we have seen: create, put, get, scan, and truncate, any disable drop table. All these operations tomorrow we'll see through the Java client. And also we'll discuss the HBase and the Hive integration tomorrow. With that, we'll close the HBase topics, and we'll freshly start with a new topic on next Monday.
Next
question.
Yes, Neil.
Are you like we have to prepare the files in CSV or TSV format, so manually doing this is very difficult, right?
So why do you need to create TSV files manually? You don't have Java utilities, you don't have anything else to create the TSV files?
Yeah.
Generally, we don't create manually, right?
Okay.
If we write some kind of Python utility or shell script or anything, read in your file, build them in TSV format, store them in TSV format.
So in the Java examples that you have provided, does it include that kind of example too?
That tab separated file,
Yeah.
you don't even need that much. Like you just need to know how to read a file and how to create a file. Just create a file output stream and prepare your string such a way that keep appending your values and tab separated them and writing them into the file. It's a simple logic. You can find in Google, you will get a hell lot of results. How to create a TSV file in Java.
Okay.
Okay. Instead of creating the file, if you want to directly keep updating your tables, you can do that. We'll see that example tomorrow in Java directly.
Okay.
Okay. and how to access these HBase tables and in Hive. So today you have seen all these new syntaxes, right? These all commands: create, get, put, scan. All these syntaxes are very new, and you can get rid of these syntaxes once you can integrate with your Hive. Okay, but of course there are some limitations, but we'll see. We'll see what can be achieved with Hive integration and what will be still pending. Okay, let's continue tomorrow then. Okay. Thank you guys. Thank you very much. Bye-bye.